Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Shakir Halim, and I representative my group for project electrical principle. So we go to 5 volt to ampere regulated DC power supply. Okay, so Muhammad Khayyam bin Isa as a project manager, and I myself is a circuit designer, and Muhammad Luqman is technologist, and Khalid Saifullah is as an technologist. So for our presentation, we will go to introduction, objective, product picture, circuit diagram, technical specification, methodology and detail process. Then we go to circuit simulation. So we go to flowchart and bill of material.
So we go to the introduction. Is about our projects, 5 volt, 1 ampere, regulate DC power supply. So actually, we will be introduce you the background DC power supply, that we cannot reject that we live in period the most everything around us is the electrical hardware. So we utilize the electrical gear to solve our day by day life, to turn off, to be simple. For instance, on the off chance we need to wash our materials, so we use our clothes washer. If we need to contact our family members, we utilize our cell phone. And on the off chance that we need to head off to some place distant, we simplify use transport. All hardware that we simplify notice contain same voltage and current. The undertaking that we have been trust was 5 volt, 1 ampere regulate DC power supply. The capacity of the straight voltage controller is to change over fluctuating DC voltage to a steady frequency, explicit lower DC voltage. Furthermore, the frequency give a current restricting capacity to shield the force supply and burn from overcurrent. We choose to go with a 1 ampere output rather than 2 ampere on the ground, that we understand that 1 ampere output is all the simpler to direct and achieve. So we move the next slide is the objective. To desire result of projects, which often includes items. So we develop circuit design of regular DC power supply using Protus software, develop power circuit based on circuit design of DC power supply, and to design and to build a 5 volt 1 ampere regulate DC power supply. Second, by the end of this project, we believe that we will be able to design and simulate a simple DC power supply circuit using combination of several passive alignment of electrical components via operated software tools. And the third, lastly, we also think that we are going to be able to test the functionality of DC circuit and explain it clearly via presentation and report writings. So, thank you.
Okay, next we go through circuit diagram. So what is circuit diagram? A circuit diagram is a visual display of an electrical circuit using either basic image of parts or industry standard symbol. So for circuit diagram, we design our circuit using Proteus software. So the circuit are projected to convert alternate current into direct current. So we convert from AC to DC by using bridge rectifier, capacitor, voltage regulator, and we also include LED light, so we can know that current is flow in the circuit. Okay, so next for the technical specification. So what is technical specification? Technical specification is define the component used for a project and product. So for the first one, we use transformer step down. So for transformer, we use model T57 1202. So input voltage from at home, we use 240 volt. So as the output from the transformer, we take 12 volt and 2 ampere. So its dimension size is 200 millimeter multiplied by 250 and multiplied by 140 millimeter. So the next component we got diode. So we use diode IN 500 and 5401. So this is a 3 ampere diode. So it can go through 100 volt. So it's the diode width is 1.4 gram, and the size is small, quite small. So then we go to electrolytic capacitor. Okay, for electrolytic capacitor, the capacitance of the capacitor is 1000 microfarad, and the voltage rating that it can work is 16 volt. So the capacitance tolerance is plus minus 10%. Okay, for next one is voltage regulator. For we use model IC MC7805. So the output current of this voltage regulator is 1.5 ampere. The output voltage for this voltage regulator is 5 volt. So it can thermal overload. So this voltage regulator have thermal overload protection. Okay, the next one is resistor. The value of resistor we use in this circuit is 150 ohm. So the tolerance is plus minus 5%. And the color code for this resistor that we use is brown, green, brown, and gold. Okay, for red LED light, we use red light. So the voltage of this light is 1.6 volt to 1.9 volt. So typical for this LED light is 1.8 volt. So the current for that need to have for this LED to work is 18 milliampere. Okay, so the next one we go to detail process of this project circuit of this project. So we receive our assignment 27 Oktober 2020. So the project is briefly explained by our lecturer, Dr. Sim. So we are given an Excel link to form a group. So by that we know our group. Okay, for step 1, we have our first meeting for the group meeting. So we conduct the meeting at 28 October 2020. So we use Google Meet platform. So in this meeting, we discuss a few things. So the first one we discuss is we distribute our role for this project, and we discuss what project outcome that we want to. And then we manage the fund. We share the fund to make this product, to make the. Okay. For step 2. Okay, for step 2, we as a team we discuss about 5 volt to ampere. We as a team we already conclude that we go to 5 volt and 2 ampere because it's more challenging for us. Okay, first we in that meeting we discuss on how the circuit will work. So what is the special requirement for the circuit to get 2 ampere and 5 volt as an outcome. So we also discuss what component is used for the circuit to work. Step 3. Okay, step 3. Circuit designer design a circuit. Okay, for step 1, I am myself is a circuit designer. So this is the step that I use into making this project. So the step 1, I list and decide all the component used for the circuit. I list it on the notes. Okay, second for step 2, I launch Proteus 8 demonstration software. And step 3, I click new project section and I create project name. And step 4, I click on As you can see, I click on the P panel in the Proteus software on the left panel, the Proteus software. You can see in the next slide. Okay, so next I pick all the component listed that I have not in the area. So I place all of the component in the workboard and connect the components with wire. Okay, so this is the circuit that we use for the step that I mentioned earlier. As you can see, this is the list of the component that we use. So from this component, we drag it into the workboard and yeah, we get the circuit. Okay, for step 4, our data process, we run the circuit simulation test to get our projected outcome. So I myself run the simulation test. So after connecting the circuit, we click on the play button at the bottom left panel to run and test the simulation. So as you can see, yeah, in the left bottom of the screen in the Proteus, you can see this display button. So if we click the play button, the circuit will simulate what is the outcome, the voltage outcome, the current outcome of the project. Okay, if the simulation result does not get into what we expected, we start over from step 3. Step 3 where we design such from scratch, determine what component to be used to get the project outcome. Okay, for if we get what we expect, we just forward our circuit, our designed circuit to the electrical engineer to make it as a product, as a prototype. Okay, step 5. Technologies build hardware prototype. An electrical engineer prepare all of the components needed according to the circuit design given. I myself give the circuit in the Proteus software. We give it to electrical engineer so they could product it into a prototype. Okay, so the electrical engineer will prepare all of the component needed. Okay, so the electrical engineer will put the component into the breadboard and check the circuit it was function completely or not. Okay, next one, for step 6, we run prototype test to get the projected outcome. So we measure two things. We measure the voltage, we measure the current. So for the voltage, we put the multimeter at the output in parallel to get the circuit voltage. So for current, we put the multimeter in the LED in series to get the circuit current. So for step 7, we prepare for solder. Not we, electrical engineer, excuse me. So for step 7, electrical engineer will prepare for the solder process. So electrical engineer prepare the solder apparatus materials to connect the component to the PC board. Okay, second, for soldering, electrical engineer will solder all of the components, make sure all the components were neat and its legs not touching with each other. So because if the legs is touching to each other, it will cause short circuit. Okay, for number 3, the electrical engineer will prepare the case with recycled material. For step 4, the electrical engineer will place the completed PCB socket that is soldered with all of the component into the recycling material case. Okay, so after we done all of the steps, we get that the project is ready to demonstrate. Okay, for step 8, our presentation and project submission that we are doing right now. So before we present our work right now, we make sure the product is in good condition. So all of our group project finalize the project report. Okay, next, what is circuit simulation? Okay, electronic circuit simulation use mathematical model or application to replicate the behavior of an actual electronic device or circuit. I, as a circuit designer, after I design and simulate a few circuit in Proteus software, I has come up with a projected circuit outcome. Okay, first one, for voltage, we get 5 volt voltage. I myself purposely to achieve a little higher voltage for the simulation, because if we conduct the product, there will be some resistance in wire that will eventually drop the voltage output. So there will be some distort outcome based on this tolerance in each components in the circuit based on its condition which will affect the voltage output. Okay, for current, I has come up with 1.95 ampere. So I try to achieve a higher. I try to get it 2 ampere, but I configure it out what's wrong. Okay, so this is the flowchart for our project. So what is flowchart? A flowchart is a picture of a separate step of a process in sequential order. So it's just the same with our digital process.
Hi, Assalamualaikum. My name is Muhammad Qayyim bin Isa. My metric number is AN 2010. Today I'm going to present about bill of materials. A bill of materials is a list of the raw material, subcomponent, parts, and the quantities of each needed to manufacture an end product. So this is the list. The first one, about 1 soldering iron, cost 25 ringgit. 1 solder sucker cost 2 ringgit and 80 cent. 1 3-pin plugs cost 2 ringgit and 50 cent. 1 multimeter cost 11 ringgit 70 cent. 1 breadboard cost 7 ringgit. 1 PCB board cost 8 ringgit and 90 cent. A cycle box for casing we already have it. Transistor step down about is for 32 ringgit. 4 diode Rm 3 ringgit each. The total is Rm 1 ringgit and 20 cent. Electrolytic capacitor about is 2, 1 ringgit each, and the total is 2 ringgit. 2 voltage regulator 1 ringgit and 50 cent each, and the total is 3 ringgit. 2 resistor 5 cent each, total is 10 cent. 1 LED red cost 20 cent, and 1 solder cost 2 ringgit and 30 cent. So the total for our project cost 98 ringgit and 60 cent. Next, total cost for the material, we divide it, and the total it is 52 ringgit and 20 cent. This is the total cost of the material for the product to work, such as component and boards. Next, 56 ringgit and 40 cent is the total cost for one-time supplies. Since this is our first project, we need to buy soldering iron, multimeter, solder iron, and solder sucker. So each of us have to pay for 24 ringgit and 65 cent. We have 4 person in this group, so that is the total that we must pay. That's all from us. Thank you.